All right, so in this example, we have a function. It's an exponential function, 0.82 to the t, and we're given, and then we're told that it's a derivative function, right? So f prime of t is this exponential function, and we're told that the antiderivative at 2 is 9. Okay, and then we're asked to complete the following table. So again, we're just going to use the fundamental theorem of calculus, right? So I know that, okay, so I'm given f of 2, and so I can actually just fill that in right now, right? Now, if I want to find the function at 4, I know that f of 4 minus f of 2 is equal to the integral from 2 to 4 of f prime of t dt. Okay, so I can rearrange it to find f of 4, right? I want to find f of 4, right? So f of 4 is f of 2 plus the integral from 2 to 4 of f prime of t, and f prime of t is 0.82 to the t dt. All right, so now I just have to integrate that. Now, in this case, I don't have a graph, so I can't just, figure it out from the graph or estimate it from the graph or anything like that. So I would have to use numerical methods, right? So we looked at the Riemann sums. We looked at the left Riemann sum, the right trapezoid rule. We looked at what else? Oh, the midpoint rule and Simpson's rule. So we could use any of those numerical methods to figure out this or make an estimate of this integral. I'm going to use one of the easier ways to do this. I'm just going to use my calculator because I have a TA84 and it has the function on the calculator. And it uses numerical methods. So I'm going to take the easy way out and I'm going to use my calculator to figure this out. Right? So I know f of 2 is 9. And when I put this integral into my calculator, I get 1.11. And add those together and I get 10.11. Okay, so that's just from the calculator. Okay, I'm using numerical methods to do it, right? But it's programmed into my calculator, which is the way numerical methods really should be done because they're kind of a pain. They should be done by computers anyway. So anyway, the value at 4 then is 10.11. Okay. And then I can just keep going. I want f of 6 next, right? So I know f of 6 is going to be f of 2 plus the integral from 2 to 4. Oh, sorry, not 2 to 4, 2 to 6, right? 2 to 6, let me see. 2 to 6, right? Because I want f of 6. So, and I'm going to integrate the same function, dt. All right, so put it in my calculator, and actually I'm just going to give you the end result. The end result is 10.866. Okay, so I'm leveraging the technology. I don't want to do any more work than I have to. All right, unless it's good for me, and then I'll do it. All right, so we want f of 10 next, and so I want to integrate. I want to take f of 2 and integrate from 2 to 10. Same function. Okay, put it in my calculator, and I got 11.70. Okay, 11.70. All right, and finally it's asking for f of 20. So if I just take f of 2 and add the integral from 2 to 20 of the same function, then I got 12.29. All right. So I have constructed an antiderivative numerically, just using numerical methods to evaluate these integrals. So here's a question. Can we find f of 0? Okay. So we've used numerical methods to work forward. Now let's see if we can work backwards. So that shouldn't be too hard though, because I know that f of 2 minus f of 0, right, just using the fundamental theorem of calculus, is the integral from 0 to 2 of the function 0.82 to the t dt. Okay, so now I want f of 0 though. All right, so I need to flip this around a little bit. I'm going to probably subtract the integral from both sides and then add the f of 0 to both sides and then flip the equation around. I want f of 0, so I'm going to put that on the left-hand side. F of 0 then is equal to f of 2 minus the integral from 0 to 2, 0.82 to the t dt. Okay. And, okay, so I know f of 2 is 9 still. So, and I can put this in my calculator, and I got 7.35. Okay. So we can work backwards and forwards. As long as the function is continuous, you know, on the interval, I can use the fundamental theorem of calculus to come up with values of the original function given the derivative. All right. So the next thing we're going to do is take a look at constructing antiderivatives graphically, which we sort of did, but we're going to take a look at that in more detail next. So I'll meet you in the next video.